Hi there. So, the first half of the class that we've handled so far dealt mostly with inductive arguments, or arguments that had conclusions that were likely, kind of entailed in a likely way from their premises. If the premises are true, the conclusion is probably going to be true. And perhaps we noticed that, especially as that unit went on, as we kept talking about kind of like more and more exotic forms of inductive arguments, they tend to get a little mushy. There's at least one thing that we might say about them is that there's room for reasonable people to disagree about how exactly to draw a conclusion from the premises in an inductive argument. For starters, we can talk about whether or not we want to be bolder or more cautious about the sorts of inferences that we draw. Not so with deductive arguments. Deductive arguments seem to have a different sort of a flavor to them. The whole second half of this semester is going to be focused on deductive arguments, and so we're going to be turning our eyes back to this question of validity and the way that truth and falsity flow through statements as a function of a formal language. So that's something that we're going to be seeing as we dig deeper in the second half of the semester into deductive arguments again. Half of that, so I guess a quarter of the semester, one half of what's remaining is going to be focused on categorical logic, and we're going to start talking about categorical logic today. The second half of it is going to be concerned with a slightly different approach to deductive arguments called propositional logic. We'll get a sense of what that one looks like. We're starting off with categorical logic, I guess for a variety of reasons, but maybe the biggest is that it's a very old logic. It's probably the first formal logic that there exists for kind of looking at the way that arguments work and trying to figure out when we can be absolutely certain that a conclusion follows from its premises. It was developed by Aristotle, and it's been kind of improved and tweaked upon quite a bit since then, as all throughout the Middle Ages, and even as recently as Venn and Venn diagrams. We're going to get a taste of all of this today. We're going to get a sense of what exactly categorical logic is up to. We're going to start to get some sense of what the vocabulary, or I guess if this is a formal language, what its vocabulary looks like, and the way that we have to get statements into a certain form in order to work with them and see what they can do in categorical logic. So, without any further ado, let's dive right in. So the reason why we call this categorical logic is that it deals with categorical statements or categorical propositions. Well, what's a categorical proposition? It's a proposition that articulates a relationship between two categories. So what's a category? Well, hopefully we don't have to go too deep into this. Maybe this is where it stops, right? We all know what a category is. A category is like a class of things. So as we can see there on the presentation, birds, the category birds, the class of all birds, contains many individual birds. Chickens, all the chickens count in the category of birds, all the hawks, all the eagles, all the ostriches, all the emus, they're all birds. Mammals is another category of things. Everything that's a mammal belongs to the category mammals, belongs to the class, or the set, if you want to kind of start looking at this in sort of more mathematical type languages, the set of all things that are mammals. People who jog, also a category. Red things, that's a category. Adam Rosenfeld is a category. It's a collection of things that all count as Adam Rosenfeld. There's more than one Adam Rosenfeld out there in the world. It's not just me. Even if we were talking about Adam M. Rosenfeld, born with my birth date, living in my address, that's still a class of things. It's a category. It's just a category that contains only one member. Notice that none of those categories are statements yet. They're not the sorts of things that can be true or false. If I said birds, true or false, you'd be confused. You wouldn't be sure, what's he talking about? Birds is not a statement all on its own. It doesn't have a truth value. Mammals, same way. People who jog, this is an incomplete thought. On the other hand, if I show a relationship between two categories, I can get a statement. So for example, something like, no mammals are birds. That articulates a relationship between the class of all mammals and the class of all birds. So specifically, that none of the things that are in the mammal category are in the bird category. Some people who jog are Adam Rosenfeld. That one's a little more complicated, about the class of all people who jog and the class of all people that are Adam Rosenfeld. All cats are mammals, same sort of thing. We have the class of cats, we have the class of mammals, and we've said that all of the cats are members of the mammal category. And the last one there, sure, we've read all the rest, so why not read that one too? Some red things are not fire engines. So those are statements. Those have a truth value, and those are categorical propositions. In order for us to start really seeing like what we can do with categorical propositions, we need to get them into a standard form. The standard form is pretty much just the way that any categorical proposition is going to have to follow this structure in order for it to work in categorical logic. And pretty much any categorical proposition can be put in this standard form. This ends up not necessarily allowing us to say all of the things that we might want to say in a natural language, but it's impressive how much you can say in some sort of categorical standard form. That standard form looks like this. It always has these four parts: some quantifier first, then some category of things, a subject category of things. That's going to be like the subject of the sentence. So quantifier, subject category, a copula, which is going to be our verb, some form of to be verb. It's either going to be an affirmative or a negative version of the to be verb is or are, right? So quantifier, subject category, copula, and predicate category. And every time I do that, I'm articulating some sort of relationship between the subject category and the predicate category. So we can see there on the presentation, all snakes are reptiles. All is the quantifier. It tells me how much of the subject class I'm talking about. I'm talking about snakes. Snakes are my subject category. How many of these snakes? All the snakes. All the snakes are, so this now gets me into a relationship with the predicate category, reptiles. So everything that's a snake is in the category of reptiles. Quantifier, subject category, copula, predicate category. We get the same there with no snakes are birds. Notice we have a different quantifier there. I went from all the snakes to none of the snakes. Some snakes are scary things. Notice there, we've changed the quantifier yet again. Instead of all or no, now I'm talking about some snakes are scary things. And then the last one that's there as an example is some snakes are not pets. And notice what we've done there. We have some again as our quantifier, but are not is our copula. So instead of saying some snakes are scary things, now we're saying some snakes are not pets. So we'll notice a couple of things are going on here. One, there's some sort of variation in the quantifier that determines whether or not we're talking about the entirety of a class, or for that matter, none of the class, and it's going to turn out that those are very similar, or just some members of the class. So there's that distinction. And there's also something going on where sometimes we're articulating a positive relationship between the subject and predicate between the subject and predicate categories, and sometimes it's a negative relationship. And these two things that are varying, whether I'm talking about the entirety of a class or just some members of it, and whether I'm talking about a positive or a negative sort of relationship, these are the two things that could possibly vary in any standard form categorical proposition. The words that we use to talk about these two things are quality and quantity. So first, let's take a look at quality. There are two possible options for the quality of any sort of categorical proposition. It can either be affirmative or it can be negative. The affirmative sorts of statements are ones where there's a positive relationship between the two classes that are being discussed, like all classes are enriching experience. How many of the classes? All of the classes? Yeah, but what's the relationship of the classes to the enriching experience? Well, all the classes are enriching experiences. Some students are tired people. That time I'm only talking about some of the students, but notice it's a positive relationship between the students and the tired people. Negative quality can appear in two places in a standard form categorical proposition. Sometimes I can catch it in the quantifier, where instead of talking about all or some, I say no or none of the subject class is the predicate class. So the example that we have there is no married people are lonely people. It's got a negative quality because it's kind of making a kind of an exclusionary relationship between married people and lonely people. There's no intersection between those two sets. Some bachelors are not happy people. And again, we have a negative quality to this because I'm not saying that some bachelors are, I'm saying that some bachelors are not. So that's actually kind of one of the few very tricky things to keep track of in the standard form categorical propositions is that Affirmation is always going to show up as an R, but not every time that we have an R does that mean that I have an affirmative quality. I'm looking for some version of negation, some version of like no or not or none. If I have that, then I have negative quality to my categorical proposition rather than affirmative quality. So that's quality. Let's look at quantity. There are two options for this. The quantity of a categorical proposition can be universal, and when it's universal, I'm talking about the entirety of some class. And what's also going to count as talking about the entirety of some classes if I'm talking about none of them. If I'm saying, like, the whole class, not them. That's also a universal sort of a quantity. And the other option that I have is I can be talking about a particular quantity of the subject class. So some students are tired people. I'm not talking about all of them. I'm not talking about none of them. I'm only talking about some of them. And as we're going to see in just a moment, this actually is, in fact, let's talk about it right now. When I say some, when I'm talking about the quantity of some categorical proposition being particular, all I'm really referring to here is at least one. That's all that some means. This is actually something that we're going to have to keep track of because I think a lot of us have a tendency through natural language use to expect that when somebody says, for example, some students are tired people, they're also implying that some students are not tired people. After all, if it was all the students who were tired people, I just would have said all the people. But that's not really how this works. I'm not committing myself to saying that it's not the case that all students are tired people when I say that some students are tired people. For example, if I identified one or two students and they were both tired, then it seems like I'm entitled now to say, yeah, there are some students who are tired people. There's at least one is the way that we usually translate this. If we ever say some blanks are blank, I mean at least one, or there exists at least one. That existing part is going to be important later on. We're going to see that's going to get us into some possible trouble when we're doing categorical logic. So, some just means there exists at least one. So in a particular affirmative statement, I can say some students are tired people, or I could have a particular negative statement where I say some bachelors are not happy people. Either way, the quantity is particular rather than universal. So, now that we have those two things that can vary in exactly two ways, so we can have the quality, which can be affirmative or negative, and we can have the quantity, which can be universal or particular. If those two things can each vary in exactly two ways, that means that there are going to be exactly 4 different kinds of categorical propositions. And this is something that Aristotle figured out. This is something that a lot of Aristotle's inheritors also kind of worked very heavily in. And here we start to see some of the influence of like medieval Latin monks on the way that we still talk today about this style of doing logic. So this comes to identifying that each of those 4 different types, I could have a universal affirmation, I could have a particular affirmation, I could have a universal negation, or I could have a particular negation. Each of those 4 different possibilities is a different kind of statement, and we label them. Universal affirmations, we call those A statements. Universal negations, we call those E statements. Particular affirmations, we call those I statements. And particular negations, we call those O statements. Where this comes from, and what could act as a handy mnemonic for you, is to remember the Latin word affirmo, which means I affirm. The first vowel of that word, affirmo, the first vowel is A. That's my universal affirmation. The second vowel of affirmo is my particular negation. That's the I statement. Same thing going on with nego. Nego is the Latin for I deny. So the first vowel is going to be my universal negation. The second vowel is going to be my particular negation. First vowel is E. E statements are universal negations. Second vowel in nego, the last vowel, is O. Those are my particular negations. So in addition to just labeling these types of statements, we're also going to start to dangle our feet in the water. There's one more thing that we kind of need to get on the board so that we can start building on this in future sessions. And that's how to do a Venn diagram of each of these 4 different types of statements. So for an A statement, for example, every single A statement is going to take this form, all S are P, where S is the subject category and P is the predicate category. So you can substitute any categories you want for all S or P. In this case, we have all dogs are mammals. So if I have a subject class, and I'll represent that in a Venn diagram as like one circle, a circle that like represents the entirety of a class. The subject class in this example that we're looking at is dogs. All dogs are mammals. So dogs, that first circle, the one with the S in it, S for subject class, is all the dogs. Everything that's inside that circle is a dog. Everything that's outside of that circle is not a dog. This is pretty standard Venn diagram stuff, but it seems worth rehearsing because we're going to start doing some, more exotic stuff with this eventually. So if it's inside the S circle, it's a dog. If it's outside the S circle, it's not a dog. The P circle is our predicate class, mammals. So everything inside the P circle is a mammal. Everything outside of the P circle is not a mammal. And there's a little football-shaped region that is both in the S circle and in the P circle. Anything that's in there would be a dog that is a mammal. Anything that's in the S circle that's outside of the P circle is a dog that's not a mammal. So how are we going to represent this as kind of like an all SRP or an all dogs are mammals type statement? Well, the way that we do this in Venn diagrams is anytime I have a universal statement at all, and this counts as one, what I'm going to do is I'm going to end up shading. And shading in a Venn diagram means that nothing exists in this place. So we'll notice in that diagram that's on the presentation, everything in that first region on the far left has been shaded out. And what I'm indicating by shading that out is that there can't be anything here. I'm basically eliminating this from the universe. So if I've shaded out everything on that far left portion, what that leaves is only one portion of the S circle that still remains. What hasn't been shaded out is that football-shaped region of the S circle that's inside the P circle. And if nothing can exist in the shaded out region, that means that all of the things that do exist in the S circle are also in the P circle, or all S's are P's. In this case, all dogs are mammals. So I'm shading out that region to say that nothing lives there. This is crucial. To shade it says there can't be anything here. This is what every single A statement is going to look like. It's going to have that kind of crescent moon, that kind of fat crescent, or I don't know, somebody described it as kind of like a Pac-Man with a curvy mouth. That kind of Pac-Man or crescent-shaped region on the far left is always going to be what's shaded out in any A statement. Okay. E statement, similar sort of thing is going to be going on. This is a universal negation now. So it's a universal statement. I'm also going to be shading here, but I'm going to have to shade in a different place. I'm saying no SRP. There are no dogs that are mammals is how I would do this if I was still using dogs for the subject class and mammals for the predicate class. If no dogs were mammals, the way that I would represent that on the Venn diagram is to shade out that football-shaped section in the middle. When I shade that out, what I'm saying is nothing can be here. There can't be anything that lives there in that football-shaped region. There's nothing that exists in this region of things that are both dogs and mammals, that are both members of the subject class and members of the predicate class. When I shade that out, I make it so that it's impossible that there are any dogs that are mammals. No dogs are mammals. I've represented all of the propositional content in my statement now in the Venn diagram. All right, so we had my A statements look like this. My E statements always look like this in a Venn diagram. I and O statements are going to be a little trickier because now I'm going to be talking about some dogs, right? Or some members of the subject class. And the shading's not going to really help me out there. I'm going to have to do something slightly different. For an I statement, for example, some SRP, if we're going to stick with dogs and mammals, some dogs are mammals. What I'm going to need to do is show that there exists at least one thing that is both a dog and a mammal. That's what some dogs are mammals means, right? So I indicate that by making an X. Sometimes folks will do a star. I think in the presentation we have an asterisk. I put an X to denote the some existing dog, and I need to decide, is it going to be inside the mammal circle or is it going to be outside the mammal circle? There exists at least one dog, so it's inside the dog circle. Is it also inside the mammal circle? Yeah, it is. There exists at least one dog that is a mammal. I represent that with an X or a star or an asterisk inside that middle region to show that there exists one thing that is member of the subject class and also a member of the predicate class. That's my I statement. My O statement, and let's see if we can figure this out without advancing the slide. My O statement is going to say some dogs are not mammals, or some S are not P. So how would I represent that? Again, it's a particular quantity for this, right? All my O statements are particular statements. I'm talking about there exists at least one S, but now I'm saying it's not a P. So I need to put an X or a star or an asterisk in the S circle, but not in the P circle. Where would I put that? Yeah, hopefully you kind of figured out that, yeah, it goes here. For O statements, what it looks like is some S are not P. There exists at least one thing that's an S, but it's not a P, so I have to make an X or a star or an asterisk inside the S circle, but outside of the P circle. And there's only one place I can do that. Again, let's run through it real fast. A statements look like this. I shade that kind of Pac-Man or crescent-shaped region on the far left in the subject class to show that there can't be anything in the subject class that isn't also in the predicate class. That's all SRP. No SRP, my E statement, I shade out everything that is in the intersection of S and P to say there can't be anything here that's both an S and a P, or in other words, no SRP. That's my E statement, my universal negation. My I statements, my particular affirmation is to say that some SRP, so there exists at least one thing that's an S and it's also a P. I put an X in the intersecting region. And then last but not least, my particular negation, O, some S are not P, there exists at least one thing that's an S, but it isn't a P, so I put an X inside the S circle but outside of the P circle. Those are the Venn diagrams for A, E, I, and O statements, and as I said before, those are all the statements that we can have. Those are the only statements that exist in categorical logic. There are other ways to kind of write these things, but as soon as I put them in standard form, they'll always come back to either a universal affirmation, a universal negation, a particular affirmation, or a particular negation. Let's try one more thing in this lesson because I'm going to repeat it in the next lesson, and I just kind of want to make sure that we're already somewhat familiar with the idea. Plus, it gives us a better sense of what's going on with these Venn diagrams. We've talked about what an A, E, I, and an O statement should look like when I do a Venn diagram of them, but we've been assuming this whole time that those statements are true. One of the cool things about both categorical and propositional logic is that when a statement isn't true, when it's false, for example, that's the only other option, right? It's either true or false. When I have a false statement, I can still do things with that statement. This is a kind of, we're doing a logic of how truth gets preserved in these formal languages and how truth and falsity flow from one statement to another. So instead of talking about A, E, I, and O when they're true, we can also do Venn diagrams of these things when they're false. And in order to do that, we need to think a little bit about what the Venn diagram is actually representing. So if I had an A statement, like all dogs are mammals, if that was true, I would shade in the Pac-Man shaped region on the far left, right? I'd shade out everything in the S circle that's not also in the P circle, and that would make it so that all the S's have to be P's. That's all that's left, everything that hasn't been shaded out yet. That's what that would look like if I was saying all dogs are mammals was true. If I was saying that it's false, I'd have to do a slightly different Venn diagram. And it's actually not that difficult to figure out what that diagram should look like. When I shaded that region, that kind of fat crescent-shaped region on the far left, what I was doing was I was saying nothing lives there. There can't be anything in that region, in the S circle that's outside of the P circle. If it's false that there can't be anything there, then that means that there must be something there, right? So instead of shading that out, I want to not just not shade, but I want to make a positive assertion that something is in fact here. So the way that I can think of this is instead of shading, I'll just put a star or an X or an asterisk or like whatever it is that I'm using to indicate there exists at least one thing right here. So a false A statement, if it's false that all dogs are mammals, is the sort of thing that I can represent on a Venn diagram by putting an X in that far left portion of the subject class, that subject circle, that's outside of the predicate circle. Instead of saying nothing can live there, I'm saying something lives there. And you might recognize right off the bat that this false A Venn diagram looks an awful lot like a true O Venn diagram. That's going to pop up in our next session. The same sort of thing is going to happen with a false E. A true E statement, if I were to say that no dogs are mammals and assert that as true, would have me shading out that middle football-shaped region in my Venn diagram, right? Because if no dogs are mammals, then there can't be anything in that intersecting region. If it's false that no dogs are mammals, instead of shading that out and saying nothing can live here, I'm going to say that something lives there, right? So again, I'm going to star where I would have shaded. A true E has me shading that region. To say that my E statement is false has me not shading, but putting an X or a star or an asterisk, right? And it's going to be the reverse when I'm looking at I and O statements, my particular affirmation and particular negation. If I say some dogs are mammals, I'm going to put an X in that football-shaped region where S and P intersect, right? If it's true that some dogs are mammals, then some things that are dogs are also mammals. If that's false, instead of saying that there's something there, I want to say that there's nothing there. So instead of starring or Xing or asterisking in that middle region, I'm going to shade it out and say nothing is here. That's a false I statement, and it looks remarkably like a true E statement. False O statement, same sort of thing. If I was going to X in a place, if I was going to say that some dogs are not mammals, if I'm going to say it's false that some dogs are not mammals, instead of Xing, I'm going to shade. Instead of saying that something lives in some particular place, I'm going to say that nothing lives there. And I would initially put it, if I was going to say that some dogs are not mammals, I'd put my X in the far left region there, inside of the S circle, but outside of the P circle. And since I'm saying it's false that some dogs are not mammals, I'm going to shade that out. We'll rehearse that again at the beginning of our next session. For now, for the worksheet that's going to be posted and for the homework, I only need you to be able to identify whether we're looking at an A, E, I, or an O statement, and to be able to identify its Venn diagram. Hope this was helpful. If you have any questions, let me know, and I'll see you at the next session.